Back. Reaching that midpoint of our Intro to Creo class with exercise number 5. And to this point, we have spent our time creating individual parts. And I've made mention before, at least once or twice, that Creo also has the capability to do many, many other things, including creating what are called assemblies. Assemblies are essentially collections of a multitude of individual parts in which we take those parts, we combine those parts, we set up relationships between them, and we can also set up motion in between those parts at joints or points at which those two parts meet. So, for example, I have a pair of scissors here. And let's think about this in terms of assemblies in a CAD software like Creo. So I have many parts here. So to create these scissors, I would have many parts. I would have parts for the handles. We have a couple different colors of plastic. Those are different parts. So we probably have 4 parts for those. We have a part for each of the blades of these scissors. We would also have a part that is the rivet, a piece of hardware, both sides of that rivet, and then this plastic cap on that rivet as well. So we would have all of those parts, and we'd have to either create those parts and model those individually, and then combine those things into an assembly. So let's think about an assembly in terms of CAD software. It is much like you're physically putting together this pair of scissors. So let's think about how that goes together. So we have those plastic frame parts; those would snap together. Those would get pressed and locked onto the ends of the blades, and then at the blades, we're going to have a hole in each one of those, okay, that made up to each other. And then that rivet's going to pass through that hole. So in CAD, we would do the same thing. We would put those plastic parts onto the end. We'd set up a rigid relationship between that metal blade and the plastic handle so that those things can't move. We do the same on both sides. And then when it comes to the holes in those blades, we would line those two things up just like we would if had to put that rivet through. If we're going to put that fastener through and pass it through, we would need to line up those holes, and we would set up that relationship, that joint, as it's referred to in many CAD softwares, to line those things up. Then we'd pass the fastener through, we'd lock that in, and then we would assign motion to that joint where the blade meets the rivet. And we would set a rotational motion. We would set some constraints that can confine how far that motion can travel. Because in a lot of CAD softwares, Creo, not so much. Creo, you can do a little bit more simulation with. A lot of them, the physical environment, the rules of of reality when it comes to physical environment don't always apply. Things like gravity, things like friction don't always apply in an assembly environment. Okay, so that's in general about how assemblies work in CAD. Let's go about the business of creating one here in Creo. All right, so exercise 5 starts on page 52. We are going to create what is called a bottom-up assembly. And a bottom-up assembly, what that is a collection of existing parts. So we take existing parts and we create an assembly from them. Its counterpart is called a top-down assembly, and that is where we create all of our parts inside of an assembly. And it's a really powerful way to do it because if you have a change to an individual part or component of that assembly, when you do top down, you can have changes to one part cascade through the rest of that assembly. Now, it's a little bit harder route to go, and we'll get to one of those or two of those later on, but we're going to start with this bottom up assembly today. All right, first thing that we need to do that, because I am not cruel and we don't want to have to model all the individual parts for this assembly, is to go grab those. So let's go over to D2L, and in our assignments tab, we find exercise number 5, and in exercise number 5, we have a link to the exercise 5 parts. And we're going to go ahead and download those. I'm using Chrome on Windows 11, so your look might look a bit different if you're using a different browser. Download those. That's going to download those files into my downloads folder in a zip format. So if I go into my zip format here and I look at that file, I'm going to leave that highlighted and choose extract all. And then I'm going to go and create a folder inside of wherever I'm keeping those files at for class or for a project or whatever I'm doing. And in my documents folder, I have one called CAD 5 Intro to Creo, is where all my stuff resides. I'm going to create a new folder, and I'm going to call that exercise 5. And open that one up, and then select that folder and extract those files to that folder. And what that does for me, what zip files are, if you're not aware, is just a compressed format of a file. So if we have lots of files and we want to make that lessen the amount of storage space they require, we can compress them through zipping or compression of the files to make them smaller in size, and then to make it easier to store for space, and then also easier to transmit from one place to another digitally. And we're just going to go ahead and take those and we unzip them, bring them back to full size so that we can work with them. All right, so we're going to start a new file. Our new file, we're going to be in assembly this time, though, instead of the part. And there are some other options in subtypes of assemblies, but we're just going to leave that one there. So we're going to do, this is E5, exercise 5. So let's just call it exercise 5. I'm going to call mine video. I'm going to hit OK. And here we go. So to start our bottom up assembly, I'm going to click on this symbol right here. This one right here is a top down version. So we're going to stick with this bottom up. And we're going to go find the file that we need in my Creo folder here. I'm going to go to exercise 5 where we downloaded all that stuff. And the first thing that I need is I'm going to need this bracket. So let's find that part that says bracket. Bracket Pro, there it is. Open that guy up. And we bring that part in. Now, before we do anything else, I'm going to make sure my CSYS is on. We're going to talk about where we place this part in space. Because when we bring in a part, automatically Creo is going to just dump it in and have it placed at an origin of the part. For future assemblies and projects in the class, once you get in the habit of when you start this, instead of letting it do the automatic constraint type and put it where it is, I want you to change that to default and then notice where that moved to. Okay, so at the default constraint, it's going to start on the origin, on that CSYS for the whole assembly. And that's going to make it really easy for us to line things up when we start bringing other parts in. Okay, so we're going to hit OK, and we have our bracket in there. We're going to go ahead and grab our second part by clicking on the Assemble button again, which is going to be the yoke male. We're going to hit Open. And as we bring these parts in, we have our slider that we can move things around. And it is helpful to grab these sliders and get the thing close to where you want to. You can rotate with the rings too if you need to do that to get things set up into place. Okay, so we can do that. And the nice thing about Creo when we are setting up these relationships and these joints between two parts, so where motion can be, is that the programming in Creo, or what we might refer to now as an AI inside of the Creo, is very good about figuring out and determining what kind of a constraint between the two parts you want. And again, those constraints are something that help us lock in or limit degrees of freedom in a part. So when we think about degrees of freedom, our parts are going to have 6 degrees of freedom. If we're looking at this male yoke part here, for example, we know that we can move this thing. This thing can move, right? A thing can move in 3 axes, X, Y, and Z, right, in space. But then we also have 3 additional degrees of freedom. So on each one of these axes, X, Y, and Z, you can also rotate around that axis, around that axis, right? So that gives you 6 total. And part of what we are doing when we are creating these joints is that we are limiting those degrees of freedom. So when I put this yoke part into this hole, I want it to be able to rotate inside of this hole, right? I want this shaft to be able to rotate in here. And I want this part to stay, this face to stay in line with the bottom of this bracket. I don't want it to be able to move up and down. Okay, I want to limit that. I don't want it to be able to move side to side. I want it to just be able to stay in place and rotate in place. So we're going to limit those degrees of freedom using constraints. All right. So one other thing that we need to do, because we're going to do a motion study of this, and we want a motion study to function, is under these properties, this motion type, we want to change this to motion reference. Okay, there's nothing else that we're going to need to do. All right, so let's go ahead and set this up now. So we're talking about limiting these degrees of freedom. So first thing I want to do is I want to take this shaft and I want it to line up with that hole. So we set up a coincident constraint between those two things. Okay. So now we got one more thing that we need to set up. So we need to set up that relationship here between this face and that up there. I backed out a little bit early on this one, so let's go back and add this. So we have our single constraint here. We're going to go ahead and add a new constraint now. And it's going to be between this face and that face there. If we hit OK, now we should have that locked into place, which it looks like we do. All right, so far so good. Let's see if we got things set up right. We're going to click on drag components. I'm going to click on this and hit OK. Drag components. Click on that thing. Something's not quite right because see, we don't have that motion. If I do that and drag, I should be able to move that around. So we didn't get something quite right in here. So let's go back into this. Let's see what we missed. Okay. We missed out on something here. So we have something that we missed here. So this does not move. Let's go back and see if we can find what we have that's incorrect. So see what we have here now is we have this allow assumptions checkbox checked. And see what happens is our part is orange and we don't see any freedom here. We don't have, see what happens when we uncheck that. Now we see that we have our, we see what degrees of freedom are limited here. So we see our ability to rotate this thing in only one direction is in green. And notice that the thing moves. And the others, if I click on those other rings, are whited out. They're not there. I can't click on the arrows and drag things around. Okay, so we got to make sure we uncheck that allow assumptions on there and hit OK. Now let's try and drag it again. There we go. Okay, so let's do that one more time. Drag components, click on a face, and just move it around. So now the motion is there. So if we don't uncheck that allow assumptions, we're not going to get that motion study. It's not going to, the parts aren't going to move. Okay, so if we want to move the parts, we got to do that. All right, next. So we need another part. So we're going to set in what is essentially like a U-joint in here between this side of it and the other. So let's add that one in. That's going to be the spider hinge. I'm going to hit OK. And let's go ahead and move this guy around kind of more or less into place because it's going to reside between these two arms on this male yoke here. All right, so let's go ahead and let Creo do its thing and say we want it to be, let's not start on that one. We could do it. It's okay. Let's click on the face and then we'll click here. But then it wants to do an angle offset, which isn't right. So let's locate it by the hole first. So let's undo that. Undo that. And let's let the first constraint be between this hole and that hole there. So now we're lined up in line, right? Now we got to get it moved over. Notice that a couple of those degrees of freedom disappeared now because they are whited out. Right? And now we're going to do the second one by clicking on this face and then clicking on that face there. Oh, missed a step. Okay, so we need to, in between each step, and let's go ahead and back up. Go ahead and back up here. Let's just delete this. Okay, let's just delete that piece and start over again. All right, assemble. Bring in that spider hinge. Hit open. Let's bring it into place. We have all those degrees of freedom intact. Let's go ahead and add our first constraint between this and that to get them lined up. Okay, we're going to add a new constraint between this face then and that face there. We want that to be coincident. Okay, we're lined up. We're in there. We're good. We hit OK. There we go. And there are colored faces on this. So your blue face should match up with the blue face in here. It'll still function the other way, but just in case you're wondering, try and do it that way to make it work that way. It's a little more precise way to do it. All right, so we have that. Now we need the lower part of that yoke to finish up that joint. So let's go ahead and grab that. That is going to be the yoke female. Open that one up. And this one's got a little bit more going to it. We got some other parts to it. And we're going to have this one on here. So let's go ahead and set up that constraint. The first one is going to be those holes. We're going to add a new constraint. In this case, it's going to be between this face here. We're going to rotate so we can see. Grab that face there. See what we missed on that last one, that allow assumptions? So I don't think this part's going to move. So let's try. Let's try and see if it does. So let's drag components. Yeah, so we got something that's messed up in there. It doesn't like that. So if I hit OK, and I go ahead and grab this thing, it's not going to work. So let's go back to this one. Go back, left click in there and add it. Uncheck that allow assumptions, hit OK. Update that assembly. Now we're going to go in and fix this. Let's just go ahead and delete that one. So left click, get rid of that. Let's bring back in that spider, that yoke female part. Back in here. Zoom in. Let's set up the relationship between those. Try and get that somewhere where it's approximately where it's going to go. All right, so constraint is going to be the hole, right? The hole and the hole here. Put that somewhere where you could see it a little bit easier. There we go. Now those are lined up. Let's add a new constraint, which is going to be this face here. And this face here. We're going to allow assumptions. This constraint is not going to be a distance one. We don't want to lock in the distance between those two. We want it to be coincident. So they sit on top of each other, right? And let's hit OK there. We kind of got a weird looking thing here, but this looks better. Let's drag components now. There we go. Now see how everything moves together? That yoke rotates, the spider hinge rotates, and the female follows, okay? All right, so let's close the drag. Let's go ahead and set up another constraint here between this and this. So we can go back into this one now. Let's edit this definition. Let's add a new constraint between this face and that face. We don't want an angle offset.
To the other side and select this face right there.
Okay,
Here's what
we don't want that.
And I might have bypassed.
We don't want something else playing in the background. We don't want that angle offset. We just want a distance one. Okay, we want a little bit of clearance between this and this face. So let's just do, I don't know, 25 thousandths. Okay, and okay. Distance, 25 thousandths. Parallel. There we go. That's what we wanted, was the parallel one. Not the distance one. You can have the distance one in there too and set that bit of distance. There's going to be distance by default. So the parallel is what we wanted. Okay. So we have coincident between the hole for the holes. We have coincident between the inside face of the female yoke and the spider hinge, and then a parallel constraint. Sometimes it takes me a minute to process, and it does sometimes in these videos, because going between 4 different 3D CAD programs that I use every day, sometimes it's hard to switch gears. All right, so let's go ahead and try that out and see how that is. Let's grab this thing. Nice. So as we go ahead and move that, see everything else is moving. This is staying parallel with that. Good. We're doing good. All right, let's get this notch. Let's rotate till we get to the notch at the front there and hit OK. And let's get this thing finished up. All right. So we need a handle on there. A handle would probably make it a little bit easier for us to use this. So let's get that handle on there. Let's go ahead and close out that drag menu. Let's do and bring in the handle subassembly. Okay, so we're going to include a handle. So we're going to bring in an assembly so we can combine assemblies together, multiple assemblies together, right? So we can combine parts to make assemblies. We can combine assemblies with assemblies. We can put them as sub-assemblies of the larger one. There's lots that we can do. All right, so we got this guy here. We need a handle. We see that we have a key in the shaft there. We also have a face that we could use to line up with that key in there. We want to line those two things up, right? So let's go ahead and set our first constraint up there. Not as an angle offset. Let's do that as a coincident so that they're lined up together. All right, so they're lined up right above each other. And now we want to set up a second one. Actually, the coincident is the face there. So let's go ahead and set up so that we are lined up above. Left click on the inside face of that, the inside face of that. Now we're locked in, and look, our only little degree of freedom is that. We want to remove this one though. So let's go ahead and get this guy moved down to here. So let's go ahead and add another new constraint between this face here. Let's do that distance. Let's leave a little bit of space because we want some clearance. We don't want the handle rubbing on this bracket, right? Motion has to happen. We have to have a little bit of a clearance there. So let's just do an offset of 10 thousandths. And go ahead and hit OK. We have that little bit of space in between our parts there. Let's see if we're working. Let's drag components. Let's go ahead and drag and grab a hold of that handle. There we go. All right, the thing works. But in reality, this is falling to pieces because there's a problem, right? There's nothing holding this stuff together. So let's go ahead and fix that problem. All right, let's put these pins through here. Okay, so we have some blue pins, we have some red pins, and then we have some fasteners to hold all of that in place. All right, let's go ahead and grab that pin. I'm going to grab the blue pin and hit open. Blue pin is going to be one of our smaller ones. We also have a red pin that's going to go all the way through. So just like anything else, we're going to get this guy in here. So we're going to pick this face here. We're going to pick that face there. And it's going to create that as coincident, right? All right, let's add a new constraint to that. Let's click on the outside top face. Easier said than done right now because we're oriented. There we go. With that and that. Okay, and we got a tangent one. And we'll go ahead and hit flip because it wasn't where we wanted it to be. We needed it to be in there a little bit farther. Tangent went on the other side, so we flipped it, go the other way, and now we're in there. Okay, hit OK on that one, and that pin is there. And we will come to the other side and add another one. Blue pin, where are you hiding, blue pin? There we go. Open up the blue pin. There is our blue pin. Let's move it here. Let's go ahead and rotate it around a little bit so it makes a little bit more sense. And let's click on there. Let's click on there. Now lined up. Okay, we're coincident there. And then let's go ahead and add a new constraint. Click on the face. Click on the outside face. We're there, tangent constraint now. Let's flip that constraint, and now we are in where we want to be. Okay, so we have our two pins there. Let's go and add that red one, hit OK on that one. Assemble, red pin, we're bringing the red pin in, we're hitting open. And then same thing, same process. Pick the faces. Limit those degrees of freedom. Add another constraint. You can do multiple constraints. Let's click on that face. Let's click on the outside here. Flip that around so it gets into place where we want it to be. Lock it in. And then the last thing to do, I'll show you one of these, is we need some set screws because we wouldn't want those pins to back out as that assembly is rotating. So let's bring in our fastener. Okay, and our fastener, when we look at that, let's make sure we get that oriented the right way. because our fastener has a head on there. It's an Allen key fastener. You want to make sure it goes in the right way. So we got it rotated around so it makes sense. Let's click on the face of that guy. Let's click on the face of this right here. Let's click on this face to add that second constraint, right? And it's at a distance offset. Let's change that distance to 0. And there we go. We have our fastener in there, locked into place. There are 4 fasteners. I'll let you go ahead and knock those out. Hit OK. We'll turn off some of the noise here. Let's get back to our default orientation and rotate a little bit from there around our center axis. And try that out one last time by dragging component, clicking on the handle, and rotating that handle around. And there we go. Congratulations. You've made your first assembly with a motion study out of some existing parts by way of a bottom-up assembly. There you go. That's exercise 5. Get on to it and good luck. If you need something, let me know. Reach on out.